Hello. 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 Hello.
Hello, this is Coach McCullers, and we're going to talk about the Pythagorean Theorem today, one of the most influential theorems in geometry, having to do with right triangles. Let's go ahead and get started. Let's first start with a brief history of the Pythagorean Theorem. It is named after an Italian guy named Pythagoras, okay, and this is what Pythagoras looked like here. Let me give you a little bit of information about Pythagoras and what he did. Pythagoras led an Italian society that was half religious and half science. Now you got to remember, this is ancient Roman times when religion and science were kind of one and the same. This society that Pythagoras led was based on secret. Okay, it was very quiet. Not a lot of people knew about this society, and not a lot of writings exist from Pythagoras because of this. But here's what Pythagoras believed. He believed that mathematical is what reality is. Reality is mathematical, meaning that everything that we realize and experience around us is mathematical in nature. He also believed that philosophy can be used for spiritual purification. Okay. He also believed that the soul can rise to the union with the divine, and that certain symbols have mystical significance, such as the right triangle. And he also believed that the brothers of the order should observe strict loyalty and follow this secret code and quiet. I guess it was kind of like a fight club back in the day. First rule of Fight Club is that you don't talk about Fight Club. Well, first rule of Pythagoras' Italian society is that you don't talk about it. Okay, because of the secrecy, no writings or examples of any of Pythagoras' work exist. What we know about Pythagoras comes from what others wrote about him. Some of his disciples actually wrote about him. All right. Pythagoras was interested in the principles of mathematics. Again, math explained the world, and that's what they did back in these ancient times. Is they were trying to explain why things happen. Okay, he was interested in the concept of number. Okay, he was interested in the concept of triangles and other mathematical figures. He was interested in proving things. The theorem that we call the Pythagorean Theorem, which bears his name, appears in other early mathematicians' writings. Okay, so with that in mind, led the society kind of religious, kind of mathematical, and kind of trying to figure out what's going on with the world. Well, it's named for Pythagoras. So what is the Pythagorean Theorem? In words, we say that the Pythagorean Theorem is this. It is the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. Okay, now if we break that down, the squaring something, squaring the hypotenuse. Now we should know what the hypotenuse is. The hypotenuse is the longest side of a right triangle. Okay, and we are talking about right triangles. So if we square the length of the hypotenuse, then that's going to be equal to the sum, which means you're going to add two things together, sum of the squares of the legs. There's two legs. You're going to take those numbers and square them and add them together. Okay? Or in equation form, we can just simply say a squared plus b squared equals c squared. How do you use it? Well, once again, the longest side of the right triangle is called the hypotenuse. We call the hypotenuse c in the equation. Okay? A squared plus b squared equals c squared. C is the hypotenuse. The hypotenuse is always located across from the right angle. The a and the b represent the legs of the right triangle. So, using the equation, a and b are legs, c is the hypotenuse. To use the Pythagorean theorem, you simply substitute the known values into the theorem and solve for the unknown. So if you have two legs, plug in the legs, solve for the hypotenuse. If you have a leg and a hypotenuse, you plug those in and solve for the other leg. Alright, so here's what you got to remember. A squared plus b squared equals c squared. Alright, the legs. The legs is represented by the a and the b. The sum of the legs, the sum of the squares of the legs of a right triangle is equivalent to the hypotenuse squared. So c is going to be the hypotenuse. Okay, so in equation form, this is what we have. A, B are legs, C is the hypotenuse. Now, if we were to associate this with a picture, we got to have a right triangle, and across from the right angle of the right triangle is going to be the hypotenuse. which is going to be our C value. And then, of course, the other two sides that are not the hypotenuse are the legs. And the legs make up the right angle. So the legs in this case are here on the left and on the bottom, and they are the A and the B. Okay, to solve, first you got to write the Pythagorean theorem. That's the place to start. You know the equation. It is a theorem you need to follow. Anytime you're trying to find the sides of a right triangle, use the Pythagorean theorem. Then you need to substitute what you know. Okay, so here's the first example here. We have a right triangle, and we have that I give you two sides. One side is 3 feet, the other side is 4 feet, and the longest side, the hypotenuse, is C. Okay, so we need to substitute the values into the Pythagorean theorem. Okay, based on the location of the information here, I give you two legs. 3 feet and 4 feet are the legs, A and B. C is the hypotenuse because it's across from the right angle. So we plug it in. We get 4 squared plus 3 squared equals C squared. We evaluate the squares. So we're going to get 16 plus 9 equals C squared. Then we're going to add and get 25 equals C squared. And then we take the square root of both sides. All right, to undo the squared on the C, you have to take the square root of both sides. So our final answer is going to be 5. Now, if you take the square root of 25, you're supposed to take the plus or the minus. Well, that would give you a negative answer, and if we're trying to find distance, negative answers just don't make sense. So in this case, we're just going to take the positive square root value. So the positive square root value will be 5 feet. Okay. So if one of the legs is 3 and one of the legs is 4, then the hypotenuse has to be 5. And just so that you know, the 3, 4, 5 triangle is a special triangle. It's called a Pythagorean triple. And carpenters use that 3, 4, 5 all the time to see if a corner of a room is perfectly square. And it's really easy to do. You start in the corner of any room and you measure 3 feet on one side. You measure 4 feet in the other direction, and then you connect the dots with your tape measure, and it should equal 5 feet. So if this is the corner of the room here, you measure 3 feet along one wall, you measure 4 feet along another wall, and you mark those 2 points, and then you run your tape measure across this way, and it should equal 5 feet. And that's how a carpenter uses the 3, 4, 5 triangle, which is, again, called the carpenter's triangle. Okay. Here's a flow chart that you should follow, kind of step-by-step process of what you should do when you're working with the Pythagorean theorem. Very easy. You write it down, you substitute inside of it what you know, and then you solve for what you don't know. Then, of course, you're always going to check your answer. And when you check your answer, it should make you happy. And then we say, thank you, Mr. Pythagoras. Okay? So let's work out another example here, one for you to try. Your turn. Look at this triangle that we have here. I give you 2 pieces of information. I give you 5 feet and 13 feet, and then I say this side is B. Okay, so well, I've given you a hint here by calling this B. First thing you need to do is write the Pythagorean theorem. A squared plus B squared equals C squared. Okay, then you need to identify the parts and substitute in. The 5 feet. Ask yourself, what is the 5 feet? Where is it located on the right triangle? Well, is it across from the right angle? Well, I would always start with the hypotenuse. In this case, the hypotenuse has to be 13. 13 is the longest side. That gives me some information about B as well, is that B cannot be bigger than 13 because B is not the longest side. So 5 must be a leg, 13 is the hypotenuse, and B is another leg. So we're going to plug those values into the Pythagorean theorem. So we're going to solve for the missing measurement here. And so if you want to pause the video here, plug in and see what you get. Pause it now, and when we come back, we will show our work and see what we got. Okay, so now I'm going to go ahead and plug these in and solve for the B value here. All right, and this shows all of the work. Okay, so here we go, step-by-step process here. The first step, write the equation. A squared plus B squared equals C squared. That is the Pythagorean theorem. A and B are the legs, C is the hypotenuse. Well, 5 is the leg, so I'm going to plug that in for A. 13 is the hypotenuse, so I'm going to plug that in for C. I'm going to go ahead and evaluate the squares. 5 squared is 25. 13 squared is 169. Okay. Now, if we're solving for B, in this case, we've got to get the B by itself. There's a step here that I couldn't show based on the typing, But if you are showing your work, you need to show that you need to subtract 25. Subtract 25 from one side. Whatever you do to one side, you must do to the other side. So I'm going to get rid of the 25. I'm going to subtract it, and whatever I do, I'm going to do over here. So 169 minus 25 is going to give me 144. Now, there's a reason why I chose these numbers, because 144 is a very nice number. We got to get rid of the square, so we take the square root. And like I said, 144 is a nice number because it is a perfect square. Square root of 144 is going to give me 12. Okay. Now again, if we take the square root of both sides, we're supposed to take the positive or the negative. It doesn't make sense to have a negative 12 for an answer. So I'm only going to take the positive answer. So B has got to be 12 feet. Just like the 3, 4, 5 triangle, the 5, 12, 13 triangle is another special triangle. It is called a Pythagorean triple as well. Okay? All right, now your turn. A little bit harder here. I give you square root of 50. It's not reduced. It's kind of set up for you to make the problem easy. Okay? It's not a simplified radical, but we're okay with that. Here's x and here's 10. So I'm going to pause the video here again, and I want you to go ahead and plug in those values and see what you get for the x.
Certainly, what have I got to lose?
Okay, well, hopefully you figured out that the square root of 50 is a leg value and 10 is the hypotenuse value. So write the Pythagorean theorem, plug in for the leg value, so square root of 50 squared. And the reason I did square root of 50 and square it, they're just going to undo each other. The square root of 50 squared is just 50. 10 squared is going to give you 100. And of course you're going to subtract 50 from both sides. And you're going to say x squared equals 50. And then you have to take the square root. And you're right back to the square root of 50 again. So x equals the square root of 50. It's not reduced. I went ahead and just punched it in the calculator, and I got approximately 7.07 as the length. 7.1 is okay. If you want to be exact, what I would do is I would reduce the square root of 50, which we would go back and revisit some of our old skills of reducing radicals. 25 is a perfect square that goes into 50, 25 times 2. So actually square root of 50 is 5 square roots of 2 if you want to be exact there. 5 square roots of 2, or you can get 7.07. Alright guys, that sums up the Pythagorean theorem. A squared plus b squared equals c squared. A and b are legs, c is the hypotenuse. Go ahead and work out your practice problems, and go ahead and practice your reduction of reducing your radicals there, and getting ready for the EOCT. Also getting ready for the playoff game. Go Titans.